Okay. Oh, right. I was looking at this code like, that's not the page that I was looking at in the previous class, but I was using a different device in the previous class, so this is not related. That's why. Okay. Alrighty. So do you guys have any questions about the homework assignment? Has anyone attempted with the homework assignment? Okay. Did you get it done?
Tested.
You have not tested it?
I have not tested.
Okay. So are there any questions from the homework assignment? Because this one is a little bit tricky. I can show you guys what components you will need to use for this particular homework assignment. But the example that I showed you guys in the previous class, during class time, that should be helpful. Okay, using a variable to keep track of who is requesting the MD5, that is the key to get this assignment done. So, any questions whatsoever with the homework? Nope. Okay, go ahead.
How do you find the path to the media file on, when you put stuff in the media file, how do you know that path specifically? Because I know you have it, but where would you find it if you didn't know it?
Okay, so when you look at the project in MD5, it specifies that path already in the web viewer component.
Like the Android assets,
Yes. And that only works, okay? So this path here works, but it only works when you are in deployment mode and not in development mode. In other words, if you use AI Companion, this won't work. You have to basically use the other method of building the APK and install the APK, then this particular path works.
How do you find that path?
How do you find the path? I think it's documented, somewhere. So when you look at, I think it's under files. So under storage, if you look at the file component, it probably explains that. It doesn't do that. Prefix the file name with / to read from a specific file. So this one is one way, but because it's a file, the path is a little bit different. Let me go back to the web component here. So let's see if the web viewer has something to say about that. Nope, it doesn't talk about its asset. But the bottom line is, the way it is done here does work. It is not documented in the App Inventor documentation of using this particular path. But
where do you get that path though? Because you haven't put it in here, right?
No, it's already in the web viewer component. It's in the home URL property of the web viewer component. It's already here. So you don't have to type anything for the URL. You just use the web viewer component as it is. You don't have to program in the URL. It's already there.
Yeah, I deleted it.
Then you re-download and re-import the MD5 and get it back. Yep.
Will we be able to test it through emulator, or we need to test it only through APK file?
This will only work if you install the APK.
But I don't have anything to install APK file for.
What do you mean you don't have anything to install APK? Sure you do.
No, I don't have a device.
You don't need a device. You can do it in an emulator. The only thing you cannot do is you cannot use AI Companion. But as long as you don't use AI Companion in any way, you will still be able to do it.
So I can test it through an emulator, right?
Yes. Using the ADB command and upload and install the APK file, you can still do it. Yep.
Okay, why can't we use AI Companion in which piece right?
When you use AI Companion, the path is not going to be the same. The
Oh,
URL
right.
is going to change.
Path to the file.
Exactly, because when you use AI Companion, then the HTML document is no longer in the path because your app is not independent anymore. It becomes basically just a component of AI Companion. So the file actually belongs to some structure inside AI Companion. It is not in your app itself.
Okay.
So that's why the path is different when
So you can use it, you have to change the path and then change it back.
right. So you will have to make your. So you need you need to keep track of whether you're developing or whether you're deploying. When you're deploying, you have to use this path. When you're developing, you have to use the other path. So it's cumbersome, but there are ways to detect that. It's just going to be really kind of cumbersome.
Okay.
Yep. All right. So any other questions about the homework assignment?
That whole process is keeping me from
Okay. What process? What do you mean by that process? What
the
is?
whole AI companion and different paths.
Okay, so let's take a step back and just look at the AI Companion, the emulator, and how everything tie in together. Okay, so that way we have a kind of more of a general idea of what tools we have and what options we have when we debug our applications. Would that be okay? Good. Okay. All right. So when you debug your program, you have two ways to do it. One way is to use the Connect tab or the Connect menu, and the other way is to use the Build menu. Okay, so there are two main ways for you guys to debug your program and to run your programs. Okay, when you use Connect, you are using AI Companion. Okay, if you use any one of these options, one of these three options, you are using AI Companion, and MD5 does not work with any one of these three methods. Okay. Sorry?
I'm using the QR thing. So
You're
it
using the
should
QR
work.
code? Okay. So if you use build, then it should work. So the QR code is, as long as you don't use the QR code inside AI Companion, that should work. Because there's a way to use the QR code inside AI Companion when you install AI Companion on a phone. So as long as you're not using the QR code inside AI Companion, then it will still work.
Could you help me like in the lab to do this?
Yeah, we can do that. But I can also illustrate in the lab, in lecture here, because I think I got the recorder up and running already. Yep, and double check the voice. Yep. So we got everything being recorded right now, so I might as well do it here. Okay. So the APK method involves that you run the emulator. I'm assuming you don't have an actual device. Do you have an actual device? You have? Okay. If you have an actual device, then you use the build method, and then assuming you have a scanner, you just scan the QR code, and that will download the APK and install the APK. So that method should work.
I've been doing it, but it's not working.
Okay, if it's not working, it has to be some other reason. You have to make sure that your app actually installs, because if your app is not installing, did it install?
It is. It pops up and everything, but I can never get to
The-
the MD5.
Okay, so I will take a look at that one because that sounds like an individual case. Yep, go ahead.
And if I don't have a device, how will it work with build?
Okay, you have two types of emulators. Okay, if you install if you install Android Studio, you have like a gazillion options to make your own virtual device. So that's one option. If you do not install Android Studio, you still have the software that comes with AI setup, and it has included in it an emulator.
Okay, I have Android Studio. I installed it. So
Okay.
How I take it?
Okay, so within Android Studio, okay, so do you know how to start in Android Studio?
I didn't try.
Well, but that's what you need to do. I mean, you have to.
Can you show please?
But I do it every single time. This is what I do every single class.
What? But I never know how to do it on my Mac. You show it on the Linux system.
I don't have a Mac.
Yeah, but how do I do it on Mac?
Then you have to find out how to do it on the Mac.
How? I don't know. Please help me to find this.
Okay.
And to find out how I can test my whole.
It depends on where it is installed, for one thing. Okay, let me see if Google can help us here. Okay, Mac OS 10, Android Studio. Okay, so download. Okay.
Yes, I did that.
Okay, so this is for Windows. And let's see. It basically depends on where it is installed. And on a Mac, I think it shows up, as one of the items that you can actually start. So you don't have to go through the trouble that I have to go through.
Yeah, I know where I can press this.
So
like,
you
like a program, like.
yes. So you can get Android Studio started. Yes. Okay. Once you get it started, it makes no difference whatsoever whether it's Windows, Mac OS 10, or Linux. So you basically just watch the video again, what I do every single class, okay? So in my case, I have to start it using a command line because there's no GUI to start it, but you have a GUI way to start it already. So that's the only difference. This is the only difference. Okay, so you can get to this part, right?
Yeah.
And once you get to this part, do you remember what I did usually in my classes?
But with a PK file,
How to start your virtual machine, your Android virtual device.
I only work with the emulator through App Inventor website.
Yes, but I have been using the emulator from Android Studio for a while now. Do you remember how I do that? Okay, so watching the video from past lectures may be helpful because you can pause. But this is what I do. There's a button here that says AVD Manager. And in there, you first have to create your AVDs, your Android virtual devices. Once you have it created, then you can just start it. I'm not going to show you how to create it because I have done it in the past and it's already recorded. So you can watch that video to see how it is done. Okay. So now that it has started, you have to look up where the ADB is installed, where the command line ADB is installed. On a Mac, I don't know where it is installed because I don't have a Mac. I don't get to use a Mac for that purpose. So you will have to find out where it is installed.
Can you help me?
Not in class, maybe in the lab. Okay.
Sure, thank you.
Alrighty. So, so without any questions from the homework itself, I'm going to continue with the discussion last time, which is kind of more of an advanced topic, but it is a really useful skill set because what we are doing here is just a recap of what we did last time. So last time I changed my MD5 app so it has two identical sections. Each section has a text box, label, and a button to compute the MD5 hash. Okay, so do you guys still remember that part? Okay. So instead of replicating the code everywhere, I was saying, okay, can I unify the code so that I have one chunk of code to basically say, give me a label, give me a text box, give me a button, and I know exactly what to do to compute the MD5 and update the label. That was my objective. Because I want to be able to type something in the first text box, press the first button, and get the hash in the first label. But I want to do exactly the same thing with the second set. I want to be able to type something in the second text box, click the second button, and get the MD5 hash displayed in the second label. So I want these two sets to be kind of identical in terms of the behavior, but I don't want to duplicate the code all over the place because that's not a very good approach. Okay, before I explain how to do it, let's try to answer the question of why is copying and pasting not a very good idea. Yep.
Because you have a lot of stuff that does the same thing.
Okay, it's not efficient from the perspective of code or blocks in this case, right? Because you end up with basically twice the number of blocks. So it's not efficient. It makes your program slightly larger, but there's a bigger issue when it comes to copying and pasting.
Yep. When to change something, you got multiple places to change it.
Exactly. If you want to change the behavior of the first set, now you have to mirror that change to the second set. But sometimes you can say, okay, but I'm not going to change anything. But you might have a bug, right? So if you have a bug before you replicate, then you would have replicated the bug as well, which means now you have two places to fix that bug. What if you forget one of those two places? Do you think App Inventor will remind you and go like, I remember you duplicated this code and you only fixed it once, you better look at the other one. It's not that smart, okay? So that's why, I don't like copy and pasting. Every time I copy and paste, I have to ask myself, do I have to copy and paste? Is that a better way to do it? Okay. So in this case, there really is a better way to do it. And last time I was halfway done, I didn't quite finish it. So today what we'll do is we're going to finish this just so that we can, we can use this approach. I might have finished it on the side when I got home. So we'll take a look at this. So the first thing we want to use, or the first thing we notice here, is we can do something like this that we have not seen before. We can make a list out of things. Okay, that's nothing new. Okay, we have done lists before. A list is nothing more than an array. Okay, look at a list as an array. So we can make a list, except in this case, we can have anything inside this particular array. You're not fixed to a particular thing inside the array. So in this particular array or list, the first thing is just text. Okay, button 1. Okay, because it's a differentiator of which set of components we're dealing with. But then the other three things inside this list are things that we haven't seen before, or at least we haven't seen these things used in this context. So when we look at this text box here, or text box input 1, it is not referring to the text of the text box. It is referring to the text box component itself. Okay, when we look at the second item, which is the label, it is not referring to the text of the label, it is referring to the label object or the label component itself, and the same thing applies to the button. Okay, so this is the first time we see anything like this, okay, in this class. But it is really helpful, because now that I create a list of 4 items, of which 3 are actual components on your screen, when we pass this particular global variable, a list of 4 things, to request MD5. So this is, we move on to the code of MD5. Okay, this is the code of request MD5 as a procedure or as a subroutine. Objects is what is being passed to it. So in the earlier code, we use the global variable dataset, which is a list of 4 objects, to pass to objects. So when we get objects, I did not have any error checking code to make sure it is a list and there's 4 items. But instead, I make the assumption that it is formatted correctly. So when you look at objects and see how we use it, this is how we use objects. We look at objects as a list, and we say, give me your second item. What is the second item of objects as a list? How do we initialize it? The second item is a text box. Okay. So I look at this whole thing and say, okay, it should be a text box. Treat it as a text box. Okay, now that we treat it as a text box, what am I doing with this text box? Look at the dark green block. Okay, so the dark green block says set the enable property of the text box, which is assumed to be this component here, to false. Yep.
Where did the dark green box come from?
The dark green box comes from the last part of this panel here.
Okay.
So when you go to any component, it will have an any blah blah if you have at least one of those blah blah components in your design.
Okay.
So that's how we got the dark green block. In this particular case, because it is a text box thing, so you go to any text box, which is here, and we are setting the enable. So you basically go to, I just passed it here.
Like
So that's the block.
Generic object, basically,
Yep,
right?
yep, exactly. So this is how we can get one thing out of the list and say, this thing is supposed to be a text box, treat it as a text box, and disable it.
Okay.
Is that okay? Now, but this is really powerful because depending on, yeah, go ahead.
Is it like using a pointer to the actual text box? Is that basically you're pointing to it and then setting its value inside the object?
Yeah, kind of like that.
Okay.
Yep. Which is really helpful because now, if you pass a different list with a different second component as a different text box, the same code can now be used to change all of those things. But it does have certain assumptions. So if you move on to the next dark green block, which is this one here, okay? This one assumes the last object, the fourth one of the list, which is our parameter objects. It assumes that one is a button. And then it says, hey, assuming this thing, this component is a button, I want to disable that button. So what you need to do to make use of this particular subroutine is just to make sure that you give it a list of at least 4 items. The first item is a text. The second item has to be a text box. The last item has to be a button. The third item has to be a label. As long as that requirement is met, this subroutine will do what it is supposed to do. Okay, and then the next one is setting a label, which is the third component. So this part here is basically saying, okay, objects is a list. Give me your third item. Okay, and what am I going to do with the third item? Treat it as a label. What am I doing to that label? Change that label to computing MD5 hash. But exactly which label are we talking about? We have several labels, in this on screen 1. We don't know. We don't need to know, okay? Because whatever is passed as the third component of objects is the label that I'm going to set to computing MD5 hash. So this is one level of abstraction that is really helpful when your design or when your app has identical groups of components, and you want those groups of components to function as a whole as something that is identical. And then the last one here, or the last bit of code, is not specific to the components because we only have one single web viewer. So I set the web view string of the web viewer to, but this part here is specific to the components as well. So let's check out this code here. The block that I have just highlighted is saying, okay, I know objects is a list. Give me the second object of the list. The second object of the list is a text box, okay? So that is the object. The text box is the object, which is the component. And I say, okay, treat the component as a text box, and I want to retrieve the text of the text box. What am I doing with the text of that text box? I'm feeding it to the web view string of a web viewer component. Basically, I'm setting up the web view string so that my JavaScript code can run and compute the MD5. But I'm no longer fixed to the first text box or the second text box. This code will basically say, give me a text box, I'll deal with it. Okay, so that makes this code really flexible because now if you have 6 of these identical blocks of code, you only need one procedure to do that thing. Yep.
So if you have 6 identical components, you can update them by passing them all to the same.
Right.
Okay, or groups of components. Right?
Groups of, you have 6 groups, and each group has a text box, a label, and a button. But then you can use this one single chunk of code, which is in a procedure, to deal with all 6.
Yeah, by looping through a list and passing a list, right? You can loop through and pass a list.
Well, not so much looping through, but when in the corresponding button click event handler, you can set up the list differently and then pass that list to this subroutine.
Okay.
I'll show you that part as well, but I just want to finish explaining the procedure first. And then the next thing we do is we call the go home block of web viewer 1, which quote unquote loads the HTML document, which also runs the JavaScript. But remember, when we say go home, it is not actually running the JavaScript code right now. It is leaving a note to itself and saying, when I'm done with the event handler that triggers the execution of this code, then we'll go ahead and run the code inside the web viewer. It doesn't run the web viewer code right now. It just sets it up, make a note to self, write down a little reminder and say, okay, remember to run the code inside web viewer 1, but it's not going to do it right away. Okay? And then the rest of the code we have seen already because we set up the global timeout counter to 5 because we want to kind of count down and check when the answer is available. And then we turn on the timer of the clock just so that we can get a tick every 200 milliseconds. So that part is identical to the program before, but I have put everything into a single procedure. So this way, when the button is clicked, I only got one thing to do. I only have to set up everything and then call the subroutine. So if I go to, when I go to button compute 1, the click event handler of this thing, the first thing I do is to set the global variable data set to this particular list. And then the second thing I do is to call the subroutine and say, okay, this is a list that has all the components. Go ahead and do whatever is needed to start the computation of MD5 hash. Yep.
You could pass that as an argument as well, right? And not build the global.
That is correct. But
take it.
But if I only pass, so if I don't use a global variable and just plug this thing over here, the subroutine will still work the way it's supposed to, but then we have a problem because when we get to the timer event handler, then we won't remember, oh, what were we dealing with before? The purpose of the global variable is so that in the timer event handler, we know which set of components is responsible for the current request of the MD5 hash calculation. So we still have to set the global variable because of that, right? Because of that reason.
That's specific to this case, really, right?
It is specific to this case, yes.
We're using a timer.
Correct.
Okay.
Yep.
Is that the timer where are you still using the re-enable to turn the buttons back on?
Yes.
In that part?
Yep. So then we move on to the second button because we have one button for the first group of components, and then we have a second button for the second group of components. But look at the code of the second component, or the click event handler of the second button. What do you notice? It's almost identical to the first one.
Did you?
Oh, I need
call
to.
that button?
Yeah, I need to call the button too. Yep. But other than that, the structure of the code is identical, the same. What if I have a third group of components? It will look exactly the same, okay? Except for it would be button 3, and then all the components will be slightly different. But you can also see how this can be useful, especially when you have an app where you have a table format, because in App Inventor, there's no way to manufacture components on the fly. So you cannot say, oh, give me 5 of these things. You can't do that on the fly. So you have to pre-make all 5 things, or 5 set of things, which is kind of tedious. But the design part is tedious. The coding part is even more tedious, because now you have to replicate the code, replicate all the blocks, make all the necessary changes. Oh, this is one other thing about the copy, paste, and modify, is what if you remember to copy and paste, but then forget to modify? Then you have 2 identical pieces of code where one is supposed to be modified, but if you don't modify, then it won't work the way it is supposed to. But this way, I can still make mistakes, but it's well contained. Okay, the bugs are well contained. Okay, so are we okay with this part? Okay, so the next part is the timer now expires. Okay, the timer ticks and go like, okay, we have a tick here. What am I going to do with the timer? Okay, so this is the timer code here. So the first part of the timer code is still the same as before. Basically, I'm saying, okay, if I am timing out, okay, if the condition is true here, if the timeout counter is less than or equal to 0, that means I have just timed out. I did not get the answer back in a second. We have a problem. Okay, so when we have a problem, the first thing I do is I re-enable the buttons, I re-enable the text box, and so on and stuff like that. And then I give the end user an error message and say, hey, we got a problem. We just timed out. Okay, and there's no way to really continue the operation because I could not compute the MD5 hash. So that's the then case. The else case here is corresponding to the case where the timer has not expired. Okay, if the timer has not expired, let's check web view string of web viewer 1, because if it is still the same as before, then that means I have not gotten the answer back. But this code is not changed yet, okay, because I did not get to modify this code. So this code is always just checking text box input 1. What if I'm dealing with text box input 2 because I clicked the second button? This is not right anymore, okay? So how do we fix this problem? So we know this component is wrong. We'll get rid of it. Okay, so how do I know whether I'm dealing with the first set of components or dealing with the second set of components? We used a global variable. Remember the global variable that we called what? data set. Okay, so let's go back to the code where we set the global variable. So the global variable is set over here. Okay, data set is a global variable that is a list like this. But with this list as a global variable, I can now get back to the text box, right? So let's see how we can do it here. This is the actual application of what we have learned so far, and I just want to kind of apply that on the fly when we're dealing with here. So what we do, or what I sometimes do, is I pick out all the components that I need, and then I try to figure out how to plug them in. Okay, so that's one way to do it. So I know for sure that I need to access my global variable. So I go to variables and say we get, and we know exactly which one we want. We want data set. Okay, so I know this one is important. I know I want to access one of the components, and going back to how it is initialized, I know the text box is the second one, so I need to get to the second item of this particular list. So we go to lists here, and then we say, okay, we need to select the second item, so we know this block is going to be useful. We also know that this is a text box, and we are only interested in the text of the text box, and that has to come from the any component thing. So we have to go to the any component part, go to any text box, and say, okay, let's see which one will give me the text of a particular text box. So we scroll down until we find this one here. Okay. So I think we got just about everything that we need, except for the 2, because we need to refer to the second component of the list. So we go back up to the math part here and say we need a constant of 2. Okay. All right, so we have all the loose pieces here. We just have to figure out how to plug all of these pieces into one thing that we need to basically go back to here and say, okay, does the web view string, does it equal to the text of the text box that is corresponding to the current request of the MD5 hash calculation? Okay, so let's take a look at these 4 components and see how we can kind of group them together. We start everything with global data set, right? Because this is the starting point. We know that the text box containing the text that we need to access is in this list. But this is a list of components. It has, in addition to the text box, it has many other things. So we need to kind of zero in to the text box itself first. So what do we use to zero in to one single thing out of a list?
List, get, and then second to index.
We need to use, which block should we use first?
Select.
Select, very good, okay. So we say, okay, the list that we are selecting from is data set, and the item number is number 2. It's the second thing of this list, okay? So when you look at this light blue block here, it is now telling, it should give me a text box component at this point. But the text box component has many things. It has got enabled, it has got a bunch of other properties. I'm not interested in any one of those except for the text property. So I say, okay, I know you have a lot of stuff as a text box component, but I'm only interested in the text property of this particular component. What am I doing with the text of that text box? Well, we were trying to do some comparison, so stick it back here. Yep.
And then you don't have to, it uses the get from the global variable?
Yes.
Because there's no get call other than that, right?
The get is from the variables part here.
Okay.
Because when you need to refer to the value of a variable, you have to use the get to refer to the value of a variable. So it doesn't matter whether it's a local or even or a global variable. You always say get and then the name of the variable to refer to the value of a variable. Okay. So what do we do next? So let's check this out. Okay. So if it does equal, it means the computation of the MD5 hash is not done yet. So in that case, all I do is to decrement the counter by 1, so that we remember, okay, 200 milliseconds has passed. I'm not getting the answer yet. On the other hand, if they do not equal, that means I have the MD5 hash already calculated. So it will get to this particular part here, because this part just wants to update the label corresponding to that whole group of components to the MD5 hash. So I use exactly the same trick. I say, okay, data set is a list of 4 items, of which the third one is a label. Treat it as a label and change the text of that label to whatever the web view string is, which is supposed to be the MD5 hash. And then I call re-enable. Okay? Now, how does re-enable know what to re-enable? Remember, I just used a shotgun approach before. Just turn everything back on. Let's check out this one and see whether it still does the same thing. So we go to re-enable, which is back here, and it doesn't do the shotgun approach anymore. Because using the global variable dataset, I know exactly which button is responsible. I know exactly which text box is responsible for the current MD5 hash calculation. So I just say, okay, I know exactly which one, this one here. The second item is a text box, re-enable that one. The fourth one is a button, re-enable that one too. So this is why I need a global variable to track the group of components that we are currently dealing with. So are there any questions about this approach? Once again, it is more of an advanced approach. None of your exams or homework is going to make use of this kind of thing. But on the other hand, if your app has like a bunch of replications in terms of the design, this can come in handy, because otherwise you have to copy and paste your code all over the place. It makes it very hard to maintain. This makes your code a lot easier to maintain. Any questions? Yep.
So maybe good use for like games where you replicate a lot of things and you want to handle them. They might have the same behaviors basically and
Yep.
the same conditions.
Exactly. It's kind of like abstract data type programming or object-oriented programming, but without the necessary class definitions and stuff like that.
Right.
Yep.
Can you tie this into like Unity or something if you wanted to use the sensors on the phone to manipulate stuff in Unity?
In Unity.
You don't know what Unity is? It's like a game engine.
Oh, you mean game? Okay, so are you referring to Unity on Android?
Yeah, you could use Unity.
Yeah, I don't think App Inventor hooks up to Unity, so there's no way we can actually do App Inventor programming in Unity.
Because there's like sensors on here that I don't think are on Unity.
Okay.
You can only use the touch stuff.
There might be a way to communicate with a Unity-based app on the phone, but I'm not sure how to do it. Okay. Any other questions? Any questions about this particular app? So I claim that it does what it is supposed to do. What do you say?
Prove it.
Exactly. So we'll go ahead and do it, okay? Which is a quick demonstration of the whole process of building the app, getting it onto the virtual device and stuff like that. So in this case, since I'm using a virtual machine, I can't. Well, I suppose I can, if I do some tricks, but I'm not going to use the QR code. I'll just go ahead and use the APK file. So by building the APK file, I would get a file, and then I need to use ADB to install the APK file into the virtual device, and then we can test the program from there. Okay, so I'm going to save it. And then switch to A command line. This one works okay. And this is where ADB is located. Depending on what operating system you use to install Android Studio, the path can be slightly different. So you will kind of have to find out where it is installed. Once I know ADB is running as a daemon, now we can go ahead and install. And I think the file is under my downloads folder, md5 1.apk. Go ahead and install that. So when I switch back to my AVD or the Android virtual device, I should find MD5 here, already installed. Click it. And this is the app. So we'll go ahead and give it a try. So RTY compute, it only updates the first one, And then I try the second one, ERT, compute hash, and it only updates the second one, so the code does work. Okay. So are there any questions about this particular demonstration? Is anyone planning to use this kind of programming in your app because you have some kind of replications of the same thing over and over? Okay, so that can be helpful. Cool. Okay, one more thing that I want to kind of mention is, remember I said MD5 hash is not safe? Do you guys remember why it is not safe? Because of rainbow table. Okay, so what you can also use, okay, I'm not going to make this a homework assignment, or I'm not going to do it, in the class, but there's a hash function called SHA-1, SHA-1, and you can already see most of the common type of search of SHA-1, versus MD5. So this is quoted from Stack Overflow, which you always have to take with a grain of salt. Okay. So which is the best overall hashing algorithm in terms of complexity and security, MD5 or SHA-1? MD5 is really not, okay? So the question is SHA-1 usable? Okay, so MD5 is broken, which is a really appropriate description of what it is. You can generate collisions, so MD5 should not be used. SHA-1 is not known to be broken and is believed to be secure. So in other words, if you can find an algorithm in JavaScript to compute SHA-1, plug it into the script, then you have a SHA-1, a SHA-1 hash instead of an MD5 hash. But it functions the same way. It is just a more secure hash. But it functions exactly the same way. You give it a string, it will give you some mumbo jumbo stuff as a SHA-1, encoded, string. It's just that it's not reversible. So people looking at a SHA-1 hash cannot figure out what text can generate that particular SHA-1 hash.
Yes.
So you cannot reverse the pattern.
SHA is broken almost.
Somebody disagrees.
Somebody disagrees? SHA-1 is broken. Never heard of that. Thank you. So, okay, what they're saying is, it requires, computations. So in this case, a collision requires, 2 to the power of 69 hash computations. So when we look at, 2 to the power of 69, how big of a number are we dealing with here? What is the quickest way to look at this and go like, oh, okay, that's a really big number?
69 zeros.
Loud.
Okay, 1,000 in base 10 is about 2 to the power of 10. Okay,
Yeah.
so you look at this thing here and you go like, okay, it has 60, 2 to the power of 60 is equivalent to 1 followed by 18 zeros. And then on top of that, you have 2 to the power of 9, which is 512. So this number is approximately 512 times 10 to the power of, what did I say, 18? Just a rough estimate, okay? But that gives you the order of magnitude that we're dealing with here. So if you cannot visualize what is 10 to the power of 18, get rid of this. So like 1, 2, 3, 4, 5, 6. So it has to go through this many hash calculations to find a collision. So using a single computer, like a regular desktop or laptop computer, it is practically useless. Even though you can eventually generate a collision, by the time you get to the collision, what you're trying to break is no longer useful. Is that concept okay? I'll give you one really easy example, but historically actually important. Why do we even have computers today? Not as a philosophical question, but as a historical question. Large computations, but why did we require quick and a large amount of computations? Code deciphering, very good. So this is at the end of World War II. The Germans had the Enigma machine, which is an encoder, which is a cryptography machine. And because of the modification, the British were no longer able to do it by hand. Because the complexity of the encryption depends on how many disks is involved in the Enigma machine. You can look it up and find out the actual mechanism. But with only, I think, 3 disks, it is doable by hand. So the British people were able to do it by hand using a particular method. And the method was derived by Alan Turing, which is also known as the father of computer science. Did you guys watch the movie, The Imitation Game?
Yeah.
Okay, so he was able to tell people, okay, you guys need to match these things, you match that thing, and then find out the actual encryption algorithm, encryption key, so that they can decipher the German transmissions. But when the Germans added one more disk to the Enigma machine, it became impractical to do it. Because by the time it is decoded, the war is over already. So you can read the message and go like, we are going to invade X, Y, and Z. Yes, we kind of know that because it happened 10 years ago. So that makes it very not particularly useful. And that's why they had to invent an electronic computer to basically do all these calculations really fast. So at the time, the British were able to decode German transmission pretty much in real time. So they would be able to decipher a German transmission and write down the exact transmission. And then meanwhile, they will actually get a second transmission or reply from the German, from the recipient, saying that we didn't quite get your message, transmit again. The Brits will just go like, yeah, we got it the first time. And that was a big deal because because you have to be able to decode the transmission before it expires, before the usefulness of the information expires. And this is the whole point, is even though you can generate the collision, but by the time you have the collision, it is too late already. Whatever you're trying to crack is no longer relevant. Okay, but if you read the rest of the feedback here, okay, somebody says, don't forget there are botnets. And a botnet is basically a hacker can take control over other computers. And all the computers under the control of a particular hacker is collectively called a botnet. Is that okay? So depending on how many computers a particular hacker can penetrate and gain control over, that can control, so a single botnet can have millions of computers. So that means if you can divide a problem into 10 million pieces and only give one computer a piece to solve, then you have just sped up the algorithm by 10 million times. But 10 million in this case is not particularly helpful. Because 1 million is only taking care of this many zeros, 10 million is taking care of these many zeros. You're still left with a fairly large amount of computation. So using one of these large botnets brings your calculation from 292 years to 2.5 seconds. Not really sure about 2.5 seconds. Maybe it's fast enough to be practical. That's what basically what the second paragraph is saying, is it becomes practical. And show 3 more comments. The link is broken, and besides, anyone can Google some info by themselves. It would be good to update your answer. Okay.
But the problem with botnets is you have to be able to divide the problem up, right?
Yes.
So if you're trying to code something to a botnet, you have to actually write the program that sends it out to every single, something different to every
Yes.
single one.
Yep. You have to be able to chop the problem up into individual pieces, and then each component of the botnet gets a different piece.
And then they each send their answer back saying, no, oh, I got one.
Correct. Usually with a problem like this is, if you get a collision, let me know. So if you're not hearing anything back, that means they're not getting a collision. So are we good in terms of understanding what is MD5 versus what is SHA-1 and the practicality of using SHA-1? Okay. Okay, all right, so this is all good. Okay. So no questions from the homework. Are there any questions from this particular sample program? No questions from this one, okay. Well, in that case, let's kind of continue. Well, I was reminded to kind of go over my own syllabus because the topics that I am going over in this class is a little bit different from the syllabus, because at the time of writing the syllabus, I did not actually have App Inventor. App Inventor was not available at the time. So if you go back to the syllabus and look at the schedule of things to talk about, some of those are not relevant anymore to our discussion. This may not be the right class, is it? We can talk about those things too, but I don't think we are in the right class. And Angela goes like, well, I know that stuff already. Okay, I think this is the right class. All right. Because I do want to kind of go over the schedule of this class, just to basically show you guys, what is kind of relevant and what is irrelevant in this class. Introduction, we talked about this, no problem. Examples of mobile applications, no problem. Okay, we talked about Pokemon Go, and that's all we needed, right? And by the way, I don't play Pokemon Go anymore because my phone is rooted, and I don't want to go through the trouble to have to hide the rootedness of my phone so that I can play Pokemon Go, because I am philosophically against companies who say if your phone is rooted, you are a cheater. So I'm just not going to play Pokemon Go. There's no addiction whatsoever.
On iPhone 4S, it even doesn't work, and on iPod too. I tried several times.
But Pokemon Go
gives
is
an error. So
Well, Pokemon Go is broken to begin with. They have a lot of bugs that they haven't really fixed. Okay, resources available such as Bluetooth, accelerometer. We talked about that already. Mobile device is a surface terminal of cloud-based applications. That's basically where things are heading. You can access your Google document. You can access your Google Sheets and a lot of other cloud-based resources on your phone now. Okay, and that's basically what it means. Application concept capturing, we have our URL. We talked about the objectives of a phone, of an app, and the values of an app. We talked about the users, basically they're actors in the UML. We talked about that. Action that each type of user can perform, those are the use cases. We talked about that as well. Application design, capturing, basically just screenshots and stuff like that. We didn't talk about a mock sequence. Basically, you're drawing a bunch of screenshots, and you draw arrows across the screenshots. You say, okay, we start with this screen. After someone types some text over here, click this button, then we move on to this screen, and so on. You just basically have a sequence of screenshots that you mock up and say, okay, this is how the app is supposed to work. We haven't really done a lot of drawing, which is what we'll do today. Okay, so we'll go back and talk about the canvas. Software development environment. Did we talk about that? Do we have one?
Yeah.
We have been using one since the first week, which is App Inventor. We talked about the host environment, which is the computer running App Inventor, which is the PC in this case. The target platform is the platform that is running the app. In most cases in this class, I use an emulator to do it. Occasionally, I use my own phone, and then I use a document camera to show you what is going on when the app runs. So that's our target platform. The source code in this case, it would be our blocks. And we don't really talk about cross-compilation in this class because App Inventor does everything for us. Whenever you click build and something is under the build menu, it's cross-compiling. If you use AI Companion, it's cross-compiling without you knowing it, because it just transmits the new code to your device without having you to do a single thing. Virtual test platforms. Have we talked about this one today?
The Android Studio and emulator.
Yep. Application uploading. Did we talk about this today? How do you upload your application to the device so they can test and run it? ADB, install -r, blah, blah, blah. That's one way to do it. Okay. Did we talk about how to use a designated host environment to install the necessary tools? Any PC that is running Windows, Linux, or Mac OS X and a browser is a good host environment. And the software that we need to install is really just the browser, depending on whether you want to run a virtual device or not. If you have an actual device, your actual phone that you want to test your app on, then you don't need any additional components because you can just use the QR code. If you want to use the virtual device, then you have to install either the AI setup software in App Inventor, or you have to set up Android Studio to get the virtual devices. We didn't talk about the files of an application project because there are no such things when it comes to App Inventor. It does not apply to App Inventor. We talked about XML a little bit, not a whole lot, because we took a look at the underlying representation of TinyDB. That was the one time that we looked at XML, because that's the only thing that is applicable to App Inventor programming regarding XML. We don't need to understand XML when we're doing App Inventor programming. We talked about user interface, layout control, and we also talked about hierarchical static elements. Those would be our containers, the arrangements, vertical arrangement, table arrangement, and horizontal arrangement. That's our hierarchical static elements. Sample program, how source code connects to user interface resources. So those would be blocks. We don't have source code, so to speak, but we have blocks. We have blocks that connect to user interface resources, which we call components in this class. So we got all of this stuff done too. Input events such as click and long click, we got that done. Event handlers, we got it done. We have dialog boxes as well, okay? And which component gives you dialog boxes in App Inventor?
Notifier.
Notifiers, very good. Okay, so we got that. Connecting input events to dialog outputs, you're just connecting the event handlers to the generation of the dialog box. So layout objects, this is going back to the arrangements, vertical, horizontal, and also table. So we have pretty much talked about all of these things. We are not going to go over this, okay? Because App Inventor does not have classes, and if you don't have classes, there's no discussion of inheritance or objects for that matter. So we do not talk about these three things because App Inventor does not have these. If I were to teach this class in Java, then these things will be important. But since we are not using Java in 362, we are not going to talk about this. In 363, they will become really important. And without classes, we don't really talk about members, although we do have some exposure to this. When you look at a property of a component, it is a member. Okay, that's basically just another term of a property is a member. A method is basically a block that is tied into a particular component. So a thing that a component can do is called a method. We don't talk about scoping because it doesn't really apply in App Inventor. So a lot of this stuff we have already kind of gone through, even though I did not specifically say, okay, this is that and this is that, but we have talked about that already. App Inventor unfortunately does not support menus, so we can't really talk about that because of the limitation of App Inventor. We talked about application-wide variables, and the interesting part about variables in App Inventor is global variables are global, which means you can see it from anywhere, but only within that screen. So even within the same app, screens do not share global variables. And that's why we talk about how to start a next screen using the start value, and also how to close a screen with a value so they can return a result from a screen to a screen that started that screen to begin with. We talked about persistent storage, and that would be what component that we have talked about would deal with persistent storage. TinyDB, very good. And if you want to make it super persistent, you can use Firebase DB as well. Okay, now Firebase DB is global across all installations of that app. So you have to keep that in mind. Let's see, we talked about text boxes. We haven't really talked about check boxes, but they're really just simple. Either it's on or off. Radio buttons, we don't have radio buttons, but we have something that is similar to that, but not exactly that. Drawing in 2D, we talked about it, but we haven't actually done anything with it, which is also something that we'll do today, just briefly. So are there any questions about all of these things that we have kind of gone over quickly in the syllabus? Okay, no major questions? All right. Okay, so I just want to kind of map what we have talked about so far to what is on the syllabus. And the change has to, yeah, go ahead.
One question.
Yep.
Advanced layout objects, linear, relative, and web view. Can you please go back and...
We don't have that control because relative means it means you want to place a component relative to the position of another component. We don't have that capability in App Inventor.
So it's not there.
Yeah, so some of the layout control or some of the layout options is not available in App Inventor.
And web view?
A web view is basically what we are using, the web viewer.
Oh, okay.
Yeah.
So,
Yep. Okay. Oh, this is something that I also did. Did you guys click the link of what I sent you like 2 days ago? No? Okay. I'll show you this. This is really kind of cool. One of the projects, that person is actually not here right now, but one of the projects involves, that person wants the end user to keep typing in the text box, but whenever the space key is pressed, it wants to break that word out of the text box to become a part of something else, and then the user can keep typing. Okay, so this app can do that. So this is a really, really kind of funky app. It has one single text box, which means the only thing you can do is to click it and start typing. So you keep typing here, but the moment you press the space key, it will take that word, or whatever is before the text, before the space bar, and put it before the text box. And then it will empty out the text box so you can type some more. In other words, you can keep typing a sentence, it will break it into words, and then each word will take up one line in the label that is before the text box. Yes?
Can we do something to keep the text box constantly in focus?
You cannot, unfortunately.
Or like,
well, you can
keep it
sort of
hidden?
do something like that. We'll talk about that, okay? But I want to show you this code first, okay? Instead of showing you the code, I want to build it, run it first, so you can see what it does. The program name is called what was it? Auto Text Chopper, because that's what it does. It chops text by spaces, and it does it automatically. You don't have to click anything. You just press the space key, and it will automatically chop it. So I want to show you this because it's really kind of cool. It's even more cool when you look at how it is done. So I want to show you that. Auto text chopper.apk. There we go. Okay. So we switch back to the emulator here. Go to A, Auto Text Chopper. And this is the entire user interface. And then you start typing here. So you say the space. Okay, look at this. Oh, it doesn't do it. Come on. Oh, it's supposed to do that. Okay. The space is supposed to automatically chop it. Okay, I must have made some changes that stopped it from working. Okay, let me take a look here. The timer is enabled. Oh, right, because of the... Is that a space? It is a space. If text is not empty, look at the last character. If it is a space character, you would want to do this and turn the text box to empty. that's empty. It doesn't do what it's supposed to. Okay, did I start the right app then? Okay, let's try this one first. So this one is supposed to change the focus to the second box the moment I press the space bar, and it does. Okay, so this one does work. So the mechanism works. But the other program should work as well. Space. Okay, it doesn't do it. All right, so let's take a look at the code. Okay, this is the entire program, by the way. This is the entire code of this program.
Is it shared code with the other one that was working?
It shares the same approach, but not
Same
exactly
logic.
the same code, same logic.
Okay.
Okay, so we'll take a look at the timer code here. There's only one event handler, which is the timer interrupt or the timer event. So as long as the timer is ticking, it should work. So that when the timer ticks, the first thing it does is to do a conditional statement, and it checks whether the text box is empty or not. In other words, if the text box is empty, then this condition becomes false, and it just drop out completely and go, okay, there's nothing to do. If the text box is not empty, then it will go ahead and check a second condition. The second condition starts with a comparison, so compare text for equality. Okay, so I want to see if something equals to something else. Now something else is the easy part because I just have a space character on the other side. This is just a single space character, which is really hard to see, but when you place your cursor on it, you can actually see that you can move the cursor, so which means it's not empty. But what am I comparing to a space bar? It is the segment, okay? This is something that we haven't talked about, but this is how you can break a string or a piece of text into smaller components. So the first thing is to say, okay, what text are we processing? What is the whole string, okay? That's where the text is. Start is a number of which character are we starting with. Okay, give me the index of the character that we're starting with. In this case, the starting character turns out to be the length of the string itself, which basically means I want the last character. Is that okay? Yep.
How does that work then? Get the length of the, so if it's got 4 characters and the last one's a space, the length
The space
4.
is a character as well.
Okay.
So if you have 4 non-space characters and then the space, your string actually has a length of 5.
Has a length of 5. Okay. If you have 4 characters and a space, then it's 5.
Yes.
Okay.
And then, so this is specifying the start index. And remember, in App Inventor, it starts counting from 1 and not from 0.
So 5 is a real.
So 5 and then 1 means I want the last one single character. Because you can also start in the middle and get like more than 1 characters if you want. So this entire thing specifies the last character.
Okay. And then the length you get from that point to another. So many
You can then specify how many characters from that point, right?
Including that character.
Including that character, correct. So I want to see if the last character is a space or not. If so, then this is the first thing that we do. There's a label before the text box, so I'm just changing the label before the text box or the text of that to be whatever it had originally. I keep all that stuff. \n is the line feed character, which means it breaks a line into 2. Okay, so it gives you a new line. And then the other part is whatever is in the text box itself. So I move everything, I copy everything from the text box into the last part of the label that is before the text box, visually.
And this code works, right?
Last time I checked it worked, but today is not working, so I have to figure out why it's not
Yeah,
working.
why?
And then I changed the text box, I emptied the text box to nothing because it's now ready to accept the next word. So that's the way it's supposed to work. Yep.
What was label pre again?
Label pre is invisible because it is the one thing before is right here.
Okay.
But it's empty to begin with, and that's why it's invisible.
Okay.
Yep. Okay, so this code is supposed to work, but it's not working today. I have the timer enabled. The timer interval is 100 milliseconds. I don't think I need timer always fires. So, okay, so here's the question. This is something that I really should teach, or every programming instructor should teach. How do you debug a program? It is supposed to work, it's not working. How many ways can explain why it is not working? Yep, go ahead.
You need to chop it up into small pieces.
I need to chop it up into smaller pieces. But one thing, what is the thing that I need to confirm first? Because that part has to be working before I check anything else.
Is it compiling?
Well, okay, it does compile because I got the APK file.
No syntax error.
No syntax error. So what is the next thing? Functionally speaking, what is required for this entire thing to work? What is the very first thing I should check? Input, output? Well, maybe I should check whether the event is actually occurring or not. Because if the event is not occurring, it doesn't matter what I put into the event handler because it's not triggering. Okay? So the first thing I really should check is whether the timer event is actually ticking or not. How do we check that? Well, we can put a label there, we can do something else, but I'm going to do something that is really visually disturbing. Okay? This is what I'm going to do.
Send the background red.
Not red, because if you turn it red, then it just stays red. It is not disturbing enough. So what I'll do is I'm going to go to text box 1 and say, hey, text box 1, I want you to change the background color. Okay, then you go like, well, you can only do this once. You can only specify one particular color. How bad can that be? You go to colors, and then you say, make color. Okay, split color means you take a color and it splits it back into the RGB components. It will give you a list of 3 numbers, which represents the RG and B. Each one is from 0 to 255. So this will give me just red itself, which is boring. Get rid of that. I don't like things that are too boring. So we'll just say random. So we'll go from random from 0 to 255, which is the full range. And then we duplicate it like twice. So now we are going to update the background color of the text box every 100 milliseconds, which is also 10 times per second, to a completely random color. And I think that we should be able to confirm whether we get to this code or not. Unless every single random number is the same, then we won't be able to see anything.
Actually,
But
maybe we should start it at 1 because right now it's possible that it'll turn it to white and that will be really confusing. Maybe you should start at 1.
Yep.
I'm thinking that even at like 111, you have a really tough time telling the difference. So like right now, like there's a good chance you will get something where you can't really tell the difference.
If it's happening every 1/100th of a second, yeah.
The chances are we'll see something in about 3 seconds.
Oh, okay.
Yeah.
If I really want this to be toggling, there's an easy way to toggle it. You basically split the current color, invert it. Okay, so unless you have gray, like 127, 127, then the inversion of that is going to be itself. But if you start with white, it's going to be black. If you start with red, the opposite of red is
Green.
no.
Yellow.
Okay,
Cyan.
red is, in terms of RGB, red is 25500. What is the other one? What is 02552555? It starts with
Cyan.
a cyan. Very good. Okay, CYMK is the other model of colors because one is additive, RGB is additive, and CYMK is subtractive, which is the print process. Okay, so I think we have an app that is now visible. So we build it. And inside the emulator, I am going to uninstall it just to make sure that we have a fresh install of this. So we drag it and say uninstall. Should ask me for confirmation. Yes. But this is a debugging process. Okay, how do you check whether your code is working, or if it is not working, Why is it not working? You go step by step. Okay, are we getting ticks? Is this event handler getting ticks? If it is, then we can look further. If it's not, then we have that as a problem to solve. I used to use the analogy of fixing cars. Like, if your car does not start in the morning, what do? And then when most people say call AAA, and then I stop asking that question.
How about Bummerize? That'd be better.
It's still called Stack Exchange.
Or you can just flip up your phone and get Uber, yep, or Lyft.
Dust off the
For
bicycle.
code, you can just put it on Stack Exchange, and that's the equivalent of like calling AAA.
I think self-driving cars will completely change the way we look at cars and transportation. Because the necessity to own your own car it's not there anymore.
I think it's as close as they're saying.
Yes, I really think that self-driving cars are going to be it's going to be reality in a few years, and then in another 5 years it will be the norm. The one thing that's stopping cars to become self-driving is the cost of the LiDAR. The LiDAR is it's kind of like a laser radar thing using infrared. It's expensive because it has like mirrors and a lot of mechanical components, and it has to be well calibrated. And that's how your self-driving car can tell itself where it is and also what is the surrounding around it. With high resolution, we are talking about resolution of down to a centimeter of objects that are really far away. So right now it's really expensive, and there are companies that are now targeting like $100 for that single device. So when that happens, I think self-driving cars will become a lot more affordable.
I was just worried about the four-way stops. Extension judgment, because people run them. So
Humans don't even know how to do four-way stops. It's always a matter of like who waits first.
Okay, when you have a four-way stop and they're all self-driving cars, and they can
Okay.
communicate with each other, then it would be okay, because all you need is the four cars to basically toss a coin to decide who gets to go first.
Right.
But if they are communicating with each other, they have an agreement. They go like, okay, each of us come up with a number, okay, and whoever has the largest number is going to go first, or something along that line. So I don't think that's going to be the biggest issue of self-driving cars.
Yeah, but when you have 90% human and 10% self-driving, that's where I think that's where Google ran into the problem with four-way stuff.
Right.
Their car would never go because people kept turning it off.
Yeah, I had a... Oh, okay, I know why it's not working. Because I was using an older version of this. Yeah. Oh, there's a third one now. Okay. That's why it's not working. I'm guessing. But this one will be slightly visually disturbing. Yay! Groovy. Okay, but does it work, right? Well, it's ticking, but does it work? So let's go ahead and type this one, okay?
I love that so much.
So tag space.
Yay.
Yes. Likes space disco.
So why do you have a pre-label and a post-label?
Well, because originally I wanted to have a navigation so it can actually go back. So I can go back and re-edit something that is already there. So that's why there's a post label. So the post label would basically, it would appear that you can move this text box up and down, and wherever the text box is, you can edit whatever is already there. So this is kind of a cool little application because App Inventor is kind of limited in a way because you cannot get an event when the text box has changed its content. So that means you cannot process and say, hey, text box, when you get some change, let me know so I can look at your last character. That doesn't work. So I have to rely on a timer to use polling to do this instead. So I'm using the timer and say, every 10 times per second, I'm going to check. Okay, hey, text box 1, what is your last character? Not a space, fine. Not a space, fine. Oh, it is a space. Let's do something about that. Yep.
the password text box object has like a change.
Does it?
Apparently, like
Okay.
that.
We'll take a look. But I just thought, this is a kind of an interesting app, how you can use a timer to do things that otherwise is not entirely possible in App Inventor.
So when the question was asked whether you can have the focus stay, were you thinking of a timer to refocus?
Yes, you can use a timer to refocus. Okay, so to answer your question of how do you make sure a particular text box has a focus, this is how you do it. And I want to look at the password text box and see whether it has an event. No, it only has got focus and lost focus. It does not have, the content has changed. Okay? Okay, so how do you make sure a particular text box gets a focus? This is how you do it. You go to a text box, and then I think, nope, it's not here. Oh, there you go. You can request focus. So a particular text box can have a method called request focus. So it will basically say, okay, whoever has focus right now, you're going to lose your focus to me. So you can use your code in a timer, for instance, to transfer the focus from one text box to another text box, which is kind of doable. You just have to do it. Because the original question was, what if you have a phone number to enter? Because when you are dealing with web phones, web apps, a lot of times when you type like 916, it will automatically move on to from the area code to the actual phone number. And this is how you can do it. You can basically just interpret whatever is in the current text box and see if it is quote unquote filled up correctly. If it is filled in correctly, then you move on to the next field. But then moving back becomes an issue, because if you want the focus to go back to the area code because you want to change from, let's say, 916 to 415, okay, the moment you change the focus, the code would say, oh, 916 is a valid code, I'm going to move on to the next one. So you have to kind of use some other way to change that behavior. Okay, but I'm giving you a clue of how to do it already. Use a timer, but you have to use some other logic to do it. Yep.
Like if it's shorter than the last, keep the length, and if it's shorter, then we're moving backwards.
Yeah, you can do that.
Don't jump.
Yeah, the problem is, a text box does not tell you whether it has the focus or not. In other words, you cannot check whether it has a focus or not, unless there's one way to do that. If you want to track if a text box has a focus or not, you basically have to intercept these two events. Whenever it got focus, you set a variable to 1. Whenever it lost focus, you set a variable to 0. So now you are using the event handlers to help you track whether a text box has focus or not.
A global flag, basically,
Yeah.
for each text box.
Yeah.
One focus.
Exactly. So it's cumbersome, it can be done. And then once you have that, then you can say, okay, if the end user is manually clicking inside another text box, then it is a manual request to change the focus, and you should let it happen and not automatically move the focus back to wherever it's supposed to. So there are ways to do that. It's just a matter of working with whatever we have to get it done, which is the fun of programming. You're limited in terms of what you can do, and then you want to do something that seemingly is not possible with the tools that you're given with, and the fun begins. Alrighty, so we are running out of time today. I will be in the lab in case you're doing your homework, and if you need to get help starting your virtual devices, I can do that. So let me stop the recorder, and we are moving on to the lab.